Hello everyone. In this video, we will be discussing last topic in springs, that is about Belleville springs. Already in the previous video, we had a discussion on leaf springs and almost all the applications, the automobile applications, everything we had discussed with some examples also. We discussed. We have chosen a cantilever beam, and for the width and the thickness. I know like the deflection and the shear stress equation also we have discussed. But here we are not going very technically, but generally we will be discussing about the Belleville springs and its torsion we will be discussing. So in the image, you could able to see the Belleville springs, and you can able to see here, and even some of the right side sketch you can able to see like where the Belleville disc springs and washers also you can able to see this. Okay, so first we will have a discussion on the first sketch, that is the Belleville springs. So generally, and you can able to see this springs I have kept for the understanding purpose in the three different pattern I have kept. That is in series. First sketch is about the Belleville springs, which is kept in series. Second one is springs which is kept parallelly, and third one is combination of both parallel and series. So here you can able to see this for all the three things where I'll be applying like a free body diagram only, where a force is applied, a compressive force is applied, where if you are checking out the terminologies or the dimensions of all these things means we can able to see this is the top view and this is the front view, where dy is nothing but the outer diameter of the Belleville spring, and small t is nothing but the thickness of the spring. You can able to see if you are taking this as one example means you can able to see this is the spring, one particular spring. There is a series of spring here. You can able to see like where the T indicates the thickness of the spring, and where we have something called di. So if this is the outer diameter means, and inside the whole part is there, no, that is nothing but inner diameter, and this is nothing but thickness, and along with that we have h. So what do you mean by h? You can able to see, I think in this particular sketch very clearly you are able to see from this point to this point you can able to see certain altitude or certain height, that only we will be calling it as h. So the symbols what we supposed to remember in the Belleville springs is, first we should be aware looking at the springs, we should be able to differentiate, okay, which is leaf spring, which is helical spring, and which is Belleville springs. I think Belleville springs are something which is very easy to like identify. The important terminologies are the symbols to be remembered here is the outer diameter, the inner diameter, the thickness, and even the height h. So next thing is where this Belleville springs are used, and what is the nature of this Belleville springs. So generally these Belleville springs are very compact and are capable of large compressive forces, but their deflections are very much limited. So examples of these Belleville springs includes gun recoil mechanism. You can able to see like in olden days and all, like there will be like some rotating what is that bullet coil, where it was completely worked on the Belleville spring mechanism only. And I mean nowadays it is completely advanced, even like we have smart guns also in these days. So I'm just talking about in the recoiled mechanism which is used in the olden days guns. And pipe flanges. So pipe flanges, I think you can able to see like it acts as a springs. So the pipe flanges and the small machine tools and applications where differential expansions could cause relaxation of your bolt. So differential expansion, some of the examples means we can go with hydraulic or pneumatic also, where some kind of like the relaxation and little kind of tension also will be there along with a small shear. Next. Then we'll speak about Belleville springs and its washers. So these Belleville spring washers, it is also called as the Phoenix specialty Belleville spring washers, and these are often described as a conical or a spherical spring. Why means because it is designed or which is seen in the form of a truncated cone, or even in the form of a truncated sphere also we could able to see. And this Belleville washers have the smallest deflection ranges of any of the three types of the spring washers, and even they also have the highest load capacity ranging from pounds to tons, and this type of washer is usually used to solve spring problems of high loads within the limited space and small deflections. Belleville washers are usually made from high carbon steel, spring temper phosphor bronze, beryllium copper, or stainless steel. And when you see the value analysis in the design and procurement, since a washer is a relatively simple mechanical component with a low cost compared to the other parts in an assembly, because as these are the frequently overlooked washer design and procurement factors which properly considered will result in substantial cost savings and minimize production line aggravations. As we are all very much aware, like generally the purpose of washer is whenever a load is applied on here, the example is spring, it is applied means sometimes if it is a point load means where the load will be focused only on that particular point. So if it is continuously applied means that may lead to the stress, and sometimes it leads to the failure also. But if you are providing a proper washer means it's a multi-purpose. The major purpose is where the load, if it is a point load means where the load is properly distributed throughout the body, that is the first thing. And even it provides a proper support cushion, and even in case of any chances of wear and tear due to the friction means even this washer also can able to avoid that. So placing a washer in so many applications, it's very significant. And also the when we consider properly about this washer position, and these are guaranteed to give the parts at the most economical price and even with minimized procurement cycles. So here the Belleville spring washers, for example, we need to check the application to find out if you are planning to buy the more washers than you need. So based on the applications only, as we discussed, because if it is a heavy load means like all the spring coils will go under some kind of stresses. So accordingly, like the type of load and quantity of the load which is applied, we will be using the washers, the number of washers in between the spring coils. If it is of heavy load means obviously in between all the coils we supposed to use the washers. So in the previous diagram we discussed what is the inner diameter, outer diameter of a belly belly. Accordingly, the washer also will be there. So the inner diameter will be calling it as ID, and of the ID of a washer is determined by the shaft side, screw diameter, and on which washer is used. And if the outer diameter size is not critical, then we need to reduce 3 by 4 inches of outer diameter to 5 by 8 inches of outer diameter. So rapidly it will reduce the amount of material required by approximately 35%. So depending on what type of gauges also we are using, with a possible cost savings to the buyer of 15%. And this is of course provided the part does not violate the wall thickness standards. After following all these things only, we will be recommending the washers for the Belleville springs. And moving to the quality control, where the quality requirements of today's markets varies immensely. It ranges from commercially accepted standards and even the tolerances for the standard washers to the most stringent requirements for many specialty products and engineered applications. And washer division members are capable of meeting your requirements, including material warrants, statistical process control, documentation, and certification of lot traceability and zero defects. To make sure that you receive the best price for the quality you need, then all quality requirements should be disclosed when you make a request for the quotation. And be sure your quality requirements note allowable specification ranges, maybe the plus or minus tolerance for a given dimensions for the washer dimensions and the materials. So most washer dimensions such as the outside or the inside diameter have a range of tolerances that is acceptable. So with this this video gets completed. Thank you.